Well, welcome back to the shop, guys. I'm still here. I haven't completely been kicked out. Like I said, I got a little bit of a reprieve. I'm not sure how long it's going to last, but it is a perfect and sunny day at the shop here, and it might be a good time to test out another solar generator system. Yes, I know that solar generator is not the correct term. It is a power station. Somehow, magically, Bluetti decided they wanted to send me another one, even though I gave away the last one. So we already took a look at the Bluetti AC200 Max, and this is the AC300. So it's a 3,000 watt power station, and it has two battery modules with it. The B300, they have over 3,000 watt hours of battery life to them. Now, I only agreed to do another solar generator review with Bluetti because I'm curious if we can get this AC300 from Bluetti to run a roof AC on an RV without a soft start. But also with this massive tower right here, it appeals to my other interest, which is going to be off-grid homesteading and even tiny houses and cabins. And this modular system from Bluetti seems like something that would be perfect for a UPS, for a microgrid at your house, or even a homestead off-grid sort of setup. And so I was interested to see if it would work for that. Because let's be honest, each one of these battery packs weighs in excess of 80 pounds, and this main unit right there has no battery storage in it whatsoever. So you need to have at least this and one battery in order to have a power system. And this is not going to find its way into a van very easily compared to the 200 Max system that we tried before. That's not to say this wouldn't fit on an RV. This would work really well on like a fifth wheel, because of course you do have the room here. In a van, you'll have a difficult time finding the space to put a system like that. And on a Class A, you might get away with it, but if it's a Class A diesel pusher that's going to have a 2,000, 3,000, 4,000 watt inverter built into it already, those systems are not going to be compatible with these solar generators. Because those inverters, like this Magnum inverter right here, is an inverter charger. You would have to completely rewire the system. Towables, yes. Class A gas, maybe, like that one there. The diesel pushers, it's going to be a big push. It'll be a lot of effort to make a diesel pusher retroactively fit. It's really not something I would recommend for that application. Cabins, towables, UPS for home residential, or even a microgrid for your house as a standalone system, yes. For RV Class A diesels, probably not. There are no wheels on this thing. So to call this a portable power station would be something of a big lie. You have 80 pounds, and 40 pounds, so that's about 200 pounds right here. This is a grown adult that you'd have to be lugging around with no wheels, so it's hardly portable. They do give you 6, 20 amp, 120 volt outlets. And of course, as we all know, these things are annoying. And maybe save those for later. And then this is going to be a 30 amp outlet right here. It is set up for the RV outlet. Now again, it's kind of a misnomer because it's 30 amp, and of course we know 30 amp is 3,600 watts, so we don't really have true 30 amp power right here. We only have 30,000 watts, which is about 25 amps on 120 volt AC power. The AC300 is not a standalone unit. It has no battery backup within it. You'll need at least one module for this to do anything useful, but it does have the inverter built into it. Has 2 MPP charge controllers built into it for a total of 2,400 watts of solar. You can charge these batteries below with it. You can actually add 2 more batteries, I think, for a total of 4 batteries on this system. Otherwise, you do still have USB charging here and then USB-C above. They do give you a 24 volt at 10 amps outlet on it, but this is going to be an important one for the RV use, should you ever want to use it for an RV. If you hook up to here, this would then replace your RV wet cell battery with these batteries themselves, and it is rated at 30 amps. You do get a whole bunch of adapters to plug all this in, and we'll go through this later. Just like the Bluetti AC200 Max that we tested before, you can charge it with generator, you can charge it with solar, you can charge it with another battery, you can charge it with a cigarette lighter. There's a whole bunch of different ways you can charge it, but we don't need to revamp that all over again. There are a few items on this that are quite the upgrade, and we'll discuss that once we get this thing hooked up. So with that being said, I'm going to go ahead and try to get this hooked up to an RV so we can see if it runs a roof AC on an RV without a soft start like we had to do with the 200 Max. That's 50 amp, 50 amp, 50 amp. I got a Nexus back there that I'm going to try to plug in. Now when I say that it's laughable to call this a portable power station, it's not because this at over 40 pounds is kind of heavy, or these at 80 pounds are really heavy. It's because wiring them up makes them a little bit ridiculously oversized for the footprint that they're taking up. You'll see in a second. Stands at 35 inches tall. It's a little over 20 inches wide. Now, while I will agree that they do nest together very well, there's no straps or anything holding it together, and it doesn't seem to want to tip over because all the weight's at the bottom right there. So it is a pretty good design as far as form and function, except for when we go to plug in the batteries to the unit. That's where it gets a little bit more ridiculous. Don't misunderstand me. These are some pretty substantial looking proprietary cables. They even have locks in them right there that you have to have locked. Battery, lock that. This is going to plug into battery 1 right up here, and then lock it. Same thing right here, lock, and lock in right there. Now these are 2 additional ports right here, so we could plug in 2 more modules or 2 more batteries, but doubling the capacity of the AC300. But now you can see with the cabling the way it is, it now bumps this out another, it extends the footprint at least another, we'll call it 7 inches. Because the way these cables come out, it seems like they should have had a built-in 90 this way or down. It's a very substantial looking plug. It does take up a lot more space because of the way these loop here, and you can't really reposition them at all. That's all well and good, but let's go ahead and turn this on. Now the cool thing about it is when you turn this one on, these turn on down here too. All right, so we're currently charged at 62%. I haven't charged this up. I haven't plugged this into anything at all. We can turn the AC on and off right there. That'll turn on all the AC outlets right there. And just like the other one, we can do the DC on, and that'll turn on the DC outlets right here, there, and there. But also, if you remember, it has an app for this, and I had it set up on my other phone here. Looks like it already discovered it. I didn't have to log in. I didn't have to give any emails or anything. I literally just connected to it. I did all this just so we can plug a 30 amp RV cord into the 30 amp outlet right here, which we agree is probably 25 amps. But that should be more than enough to run a roof AC. Alright, now please excuse the condition of this Nexus. It's the Phantom 24P. It is being worked on currently. The microwave on this one burnt out. Not in any way related to what we're doing here. So you can see we're at 60% on pack 3 and then 65% on pack 1. That's how it was shipped to me. At any rate, because I don't have the microwave right here to give me an indicator if I have power or not, I did put a outlet tester right there. Then go back. I'm going to go ahead and turn the AC on. All right, turned on. And now I do have 110 power right there. It's using 575 watts right now. Now remember, this has a built-in battery charger that's taking 110 power and charging up the house batteries, but we don't want to do that right now, so let me go ahead and turn off. So general, inverter, water heater, and converter. So that's 1, 2, 3, 4. 1, 2, 3, 4. Turns off the battery charger. And that did drop us down substantially, about 400 watts. So now we're really just running the refrigerator. But of course that also means the house batteries are starting to run low. So you'd have to plug in the house batteries to that 12 volt 30 amp outlet on the outside of the AC300 too to keep those batteries charged up. And then you'd still have to enable DC right there. Really the only test I really care about doing on a RV roof AC using this setup. Can we run the roof AC without a soft start on it? 3000 watt should do it. We'll find out. So we're in cool mode. Fan on auto, we brought it down to 59 degrees. Alright, so no compressor yet. I think I just heard something happen. Alright, we're up to 2,000 kilowatts. Okay, so that means it should have cold air right there now. It's gonna be hard to test with this. We'll have to let it cool for a little bit, huh? But it is cool. And then we did put a soft start on this, so it started up no problem, and the refrigerator's running. So 95 degrees, 95, 96 degrees on the floor. This is definitely coming down. I pull up my fail-safe. We're down to 40 degrees in there. Sorry, it's all scuffed up. But now we're already back up to 50 degrees. Long story short, it is working. I've had it running for about 15 minutes. Freezer's getting cold, and we have dropped almost 10%. So if you were just hooked up to battery with no solar or no charge coming in, you're gonna burn through that battery, even though it wasn't fully charged, probably about 2.5 hours. Not great, but that wasn't the test we were trying to do. I just wanted to see if it would start the roof AC without a soft start on an RV. These are very power hungry, inefficient AC units. So if it can start that, it can start a mini split or a window unit very easily. And so the next test I really want to do is more of a long-term setup in that off-grid cabin sort of feel that I was talking about. But before we do that, I do want to remind you what we're working with here. So with the generator, you'd have to listen to that all the time, droning on and on and on while you're burning fuel. Now remember, fuel is now getting close to, well, geez, in Arizona, we were over $5 a gallon here for a little bit. So $5 a gallon an hour can start adding up to some real money, and then you still have to listen to that and do the maintenance on the generator. But let's go outside and do a long-term test on this thing. But we're done with that test, so let's go ahead and turn off the AC. No power there now. Go outside because I have to set something up. So I want to do a long-term test of the system, because with the last video we did, everybody said, how long is it really going to run during the day running the AC with solar hooked up? Will it just die, run all day and kill the battery, and then you have no battery left over for the night? And I think those are some pretty viable concerns, and that's why I want to try a long-term test of this whole system. So I made arrangements with All Star Storage here in Apache Junction, Arizona, to provide me an office made out of a shipping container with electrical system hooked up to a 30 amp 110 outlet, just like an RV. It has a window AC unit, but that's about everything that's inside of it. So I want to make sure we do a fairly legitimate test. So I got us a refrigerator to hook up, I'll get a countertop set up, and we'll get a few more appliances put in here so we can try everything out. It's not going to be a self-contained system until you get some solar on the roof, which is not included with this kit. So you just have to buy some solar panels. But the good news is it's compatible with all solar panels on the market, with the exception of the ones that have microinverters built into them. And with the instructions right here, remember it has a dual MPP charge controller on there. It can handle up to 12 amps DC between 12 volt and 150 volt. So you can make 2 solar arrays that can put out about 1,200 watts a piece. So that's 2,400 watts total available for this Bluetti charge controller to handle. The solar system I have on my residential house is about 6,000 watts. So it's a little bit more than a third to what I have on my residential house. So I'm just going to go ahead and get my other 3 solar panels right here that you've watched in my other videos. Because it has 2 MPPT charge controllers on it, I needed some more solar panels. So I got 4 about 200 watt panels on there. So we can make 2 arrays out of these 4 panels and my other 3 panels that I already have. And the reason why I don't know exactly what these panels are rated at is because, you guys should know me by now, I'm fairly cheap. And these came from Santan Solar in Gilbert, Arizona. And these are, I wouldn't call them refurbished, but they're used solar panels with some depletion on them. And so they're discounted panels with not the exact same performance that they would have been rated at originally. But at Santan Solar, they're only $50 a piece, and that's not too bad for a test setup. I'll get the system hooked up. Remember the way you might find it in an inefficient do-it-yourselfer sort of situation with panels you have on hand, because these other 3 panels are off sizes. They're all around 330 watt, but they're not the exact same one. So that's very bad for efficiency reasons too. I have 2 completely different arrays, and we'll see what kind of effect that does in real world applications. So let me get this whole thing set up. It'll take me a little bit, okay? Give me a second. Now, an important note I didn't point out is that these batteries, looks like it's 51.2 volts DC, so we're going to call this a 48 volt battery system, which is great for solar or PV setup, because you can put makes the wiring a lot smaller that you need to pull power through. And these 3 panels together, I'm going to just put them in series, and they have an open current voltage of about 40 volts. So 3 times 40, because we're going to triple the voltage. The amperage will stay the same. That'll be about 120 volts theoretically in full sun, which is of course below the 150 threshold that the owner's manual said. And then these 4 panels have a open current, open circuit voltage of 37 volts. So 4 of those put together, we're getting close to 160 volts, which is not good. So what I'm going to do on this one, we'll split this up and see if we can't make 2 sets running in parallel to each other. So we'll have about 80 volts DC, and we'll probably double the amperage. But we'll figure it all out, right? We just can't go above 150 volts. And it's just about high noon here, towards the end of May, and I have this on the southern, it's facing south, so I can get the solar panels hooked up, and we'll plug this thing in and see what happens. Okay guys, so when I tell you that I'm not much of a wonk, a technical savvy person, numbers don't really excite me or impress me, this is what I've come up with. First off, these 4 are going to be on the ground right here because I didn't get enough wire to put everything on the roof like I planned on. So I have these 2 panels in series, and we're putting out about 66 volts. These other 2 panels are in series, and we're putting out about 64 volts. So I can use the MC4 connector, Y connectors right here. So now we'll put these 2 series panels in parallel with each other. So it should stay at 66 volts thereabout. Is it ideal conditions? Is it pristine? Is it best practices? No, this is just what we're working with. Let's connect these 2 together right here. And now that's going to be the single one out. We have the corresponding one right here. All right, so now we should be all hooked up. So if we were to consider that like 1 battery right there in series, 1 battery right there in series, now the 2 batteries are in parallel with each other. So the voltage should still be about, hopefully about 66 volts, right? 64 volts. Great. All right, and then on the roof, all 3 of these in series. So we were at about 40 volts a piece, so I think we should be looking at about, what, 120 volts thereabout. All right, so 105 volts. The sun has moved a little bit on me. It's taken me about 30 minutes to set up this array so far. Did I mention these are high quality lithium iron phosphate batteries, which is probably why they're so heavy. And that both the AC300 and the B300 have a 48-month warranty, so that's 4 years guaranteed. That's how proud they are of this thing. And while we didn't look at it too in depth before, you can see the great big huge connectors or conductors inside right there. I assume that's the actual DC power hookup. And the smaller pins are going to be communication pins and probably temperature sensors, other parts of proprietary devices. Battery lock. I did have to make these cables. Of course, you can buy pre-made cables. I just happen to have the tools and everything necessary to do it. We have 105 volts coming out. That's the positive side. So you can see this harness right there. This is going to be the solar harness. So it's set up to have 2 separate MPP charge controllers. So that's how we're going to test it. So 1 set. So we have DC2, DC1. So we want to make sure we get DC1 and DC1 together. Negative. Now the other one, I have all 4 of them are combined, and we had 64 I don't know, 2 volts coming out of it, right? All right, 62 volts coming out. Still positive right there, even color matches. So positive DC2, negative DC2. This is going to hook up to the AC300 over there, but I don't think I made it good enough, so I have to move the whole thing over here. All right, got that moved over, and as well look at some of the input connections over here. Right here, this is where you could plug into grid power up to 30 amps. Now you do have to go to the menu and set it up from, I think it's default to 15 amps, so you'd have to tell it that you have 30 amps available, which would be nice, but you can go in between, go all the way up to 30 amp for charging. And the nice thing about this AC300 is, unlike the AC200 Max, the battery charger is not a separate power supply that's loud. It's all incorporated into this unit. So you just have this plug right there that you would plug into it. Very nice. And that's part of the UPS system too, because if you have this plugged in and then that's plugged into the power grid, as soon as your house or your grid were to lose power, you can set this up as a UPS system, and it would automatically turn on the inverter and start using the battery power on here. So if you're hooked up, if you had a refrigerator or a computer system or something else very vital that you didn't want to lose power to, it would automatically switch over to solar battery power until the grid power got restored. Which is of course why this is even a better system for off-grid or emergency use, because unlike a generator, you don't have to store fuel and you don't have to service or maintain the generator when you're not using it 99% of the time. This just sits there not being used. As soon as it needs to be used, it can be turned on. You don't have to worry about fuel. You don't have to worry about carburetor going bad, fuel going bad, any sort of maintenance whatsoever, which is why I kind of like this system compared to generators. And of course, you could use this as a microgrid inside your own house. So if you wanted to, you could put a few solar panels outside of a window, hook this up to your own window unit right there, and get free solar power to help cool or heat your entire house without using the expensive grid power. You'd keep a room as cold as you want it to be. You wouldn't have to worry about wasting electricity because you're making the electricity. It's free power. So if you want to keep a room at 68 degrees during the middle of summer, you can do that. And it's not costing you anything other than the initial setup cost. And of course, you still have the emergency power at that point. Now the other plug-in right here is the one we're going to be using. That's going to be the solar plug-in, which I haven't plugged in yet. That'll be for that. Now they do give you this cable right here. You can hook up to a cigarette outlet in a car, and you can then set up the 12 volt or the power charger setup from solar MPPT charger to a DC to DC charge from 12 volt to 48 volt. Very unlikely you'd ever use that. The other one they do give you is right here. This would be for the battery packs themselves. So you could wire the battery packs themselves, the BC300, the battery packs, the B300, straight to a solar panel itself. It's limited to 12 to 60 volts DC, but 10 amps. I don't know what kind of solar charge controller this one would have as far as the battery goes. I guess I'll have to look that up in the future and we'll find out about it. The only other plug that's back here, it says you can get that power supply that probably the AC200 Max uses, and you can charge up the battery using grid power there. So you can use these as standalone battery backups if you wanted to, because you still have 12 volt outlet right there, and of course USB outlets right there. But you wouldn't be able to turn it into 110 without this unit right there. Okay, with all that said, let's hook up the solar system that we just wired up. Now keep in mind, this is kind of the reason why I like this setup. It's all inclusive. I didn't have to wire up anything, do any sort of calculations really. No overcurrent protection, no disconnects. I just have the solar panels and the wires run to it. It's all going to be included. It's pretty nice. So we'll just go ahead and put that Canon plug in. All right. Looks like it turned itself on. All right, sorry about that. We had an alarm because I had one of the locks unlocked on the battery cable. So it's saying battery maintenance or BMS system disconnected. So I had to so I had to lock it back in. So right now it's showing that we are charging at about 1100 watts. You can see it on the app there too. What you would want to do before you did what I just did, you go to the setup, go to the first page, and where it says DC input source, PV is what you'd want, rather than having the 12 volt charge. Now, to be perfectly frank, I'm a little surprised that 1100 watts is all we have right now. I didn't do my math very well. With the 4 panels there, that would be a little less than 800 watts, maybe. And then with the 3 panels up there, 300 is about 900. So about 1800 watts is what I would be expecting, but that'd be in full sun. The sun has moved a little bit on me, so we are casting a little bit of a shade. But that all being said, pretty simple installation. I basically set up an off-grid solar array in about an hour because I didn't have to wire anything up really. Now the next thing I want to do is actually wire up this off-grid office to our system here. All right, I'm gonna do that. All right, now you go to home. You know what, we'll go inside. We have the connector for that. And yeah, I have not optimized the sun at all over here, okay? So please give me some grace and some credit. All right. Oh, sorry, I'm in a metal box. Tooth doesn't like the metal box. On. All right, so the AC is on there. All right. There we go. Now that everything's on. Got the AC turned on. We have light switches here. The lights are working. And currently we are only using 105 watts because the AC hasn't kicked on yet. So we should, if we go back to battery pack, it says both of them are charging. And so we are using the AC, but I don't think the compressor's kicked on yet. But we are using some power. Sorry, this metal box doesn't want the Bluetooth to go through it. Okay, so the AC compressor did kick on. Coming out. It's coming down. 65 degrees, 61 degrees, so 15 Celsius. Putting out 1100 watts on solar, and we're only using 800 watts currently. So if we go to the battery pack again, still says we're charging both the batteries. So with the AC running, you can even hear the compressor running. It's nice and hot out there. And the lights on. We're currently still charging these batteries while using the AC and the lights. But that doesn't seem like quite enough of a test to me. So I got a refrigerator we'll plug in. And we'll see if with running everything, if we're still charging the battery or finally depleting it while we're using the whole system. All right, so we're up to 57% as far as the batteries are concerned. We dropped down 100 watts, and I found that if I keep the phone close to that back wall, we are at least getting communication. So, all right, and I got the refrigerator set up here. Okay, I got an induction stovetop and a toaster. We're now at 70% on one battery, 69 on the other battery, and they're both charging. All right, so we've been cooling and still charging the battery. I know the sun's going down, our battery or our wattage from the solar panel is coming down too. My problem is that, like a lot of these systems, they're set up to be connected to Wi-Fi all the time. I like to do a long-term test with a log and everything, but it won't let me do anything on the app that's not basic sort of functions without having Wi-Fi connectivity, which of course on my off-grid shop I don't have Wi-Fi out here. I can do a hotspot from my phone to my other phone, but it's not recognizing that hotspot as a Wi-Fi signal, so that's not going to work for me either. I'd rather just have it set up permanently like an off-grid cabin or office where I don't have to manage it the whole time. I would have been very interested to just to make it autonomous and not have to maintain or look at it. But I will keep you guys updated on what we find out. I'm going out of town, but I'll be back in about a week hopefully we'll find out if something happened while I was gone. But on the off chance that this works while I'm gone, I'm gonna set it for 81 degrees, 82 degrees, and we'll see if that kills the battery or not. I'm gonna put up to 85, that seems reasonable. I think it would probably keep it at that overnight, and then once the sun comes up, it'll charge up the battery again. We'll find out, because I'm gonna leave it plugged in this whole time while I'm gone. Okay guys, so I left you about 2 days ago. I flew across the country, picked up an RV, drove it and delivered it to a new location. And if I remember correctly, because I couldn't get on the Wi-Fi, I couldn't log in and make a log for the Bluetti. The biggest concern I think most of my viewers have, it works in full daylight, but if you're actually using this thing, does it die during overnight when you're after the sun goes down? And so since I can't log it, I thought this might be the easiest way to do it. So what I decided to do is I got up pretty early at 4 o'clock in the morning. The sun's just now coming up. I did keep in contact with my buddy who's been at the shop here, and he's been checking in and making sure that the whole thing's working. I think this is the second best way to show you guys that the system is working, as I hoped it would work. That is to say, during the middle of the day, it's making so much more power than it's using. It's actually being able to keep the batteries charged, and you're running off solar during the middle of the day, and you have the full batteries during the night period when it's not making power. I got a flashlight right here. There's the panels on the ground. There's the sun coming up just now. And I put a little bit of protection on this. I mean, I have green lights there. The system says it's at 78%. So I left the AC on about 85 degrees inside. All right, you know what? There we go, 85 degrees. All right, so we'll turn the lights on. So the lights do work. So the floor is reading 85 degrees, or 80 degrees. I got really cold in there because I put it on maximum. Okay, this is 21 degrees there, and -6 degrees in there. So that's working. Yeah, so 78 degrees in here. We go to the battery pack. Discharging and discharging. One is at 77%, one's at 80%. That's not too surprising. So I think that's a pretty good indicator that the system's working the way I was hoping it was going to work. It's making excess power during the day, running everything, and keeping the batteries charged so that overnight you have enough capacity to keep your system going. I would like to have kept this a little bit cooler, but I didn't know if that was going to work or not. And I think what I could also do, I left some water in here. That on. It's just an induction stovetop. We tried this in the last test we did. We'll let that start boiling. Let's go back to here. We got the AC going. Alright, we're at 200 kilowatts. Warming up there. Well, it's definitely warming up. It would have been 20 degrees. So I think it's passing the test that I was most interested in. We have dropped 1 percentage point there. So we're at 78 and 76. So that was 80 and that was 77. Coming up to 112. And of course the refrigerator's on, the hot plate's on, the toaster's on, and the AC is on. Toaster's off. Should have saw that drop down quite a bit. We're nearly boiling water here. Then we go outside. The sun's come up a little bit more, but we're definitely not making any power from it. From what I would hope, this should be a fairly conclusive test that our biggest concern, that overnight the battery would be dead. It doesn't seem to be the case because we're still at 75%. We made toast again. We're definitely boiling water, keeping it cold and keeping the refrigerator going. If we just did the refrigerator, I don't think this thing would ever go dead. But I've had a wild cross-country experience. I'm a little bit tired. Actually, I'm a lot tired. I'm extremely exhausted. Let me get some sleep and then we'll check back in again and see how this thing does in the full sun. I think that's a pretty impressive test. It's been running for 2 days. AC running during the heat of the day. My buddy was at the shop. He was working on the Phantom over here, the Nexus, and he said it was nice and cool in here during the middle of the day. But I'm a little loopy. Let me go try to get some sleep. Luckily I have a bed right about there. So I think what I'm gonna do is I'll turn this off right here. I'm gonna leave this as cold as we can get at 60 degrees. I'm gonna get some sleep and we'll check back in when the sun's back up again. We're making power. It's exciting. All right guys, I got a little bit of rest. It's now 10 o'clock in the morning, about the golden time for solar production, between 10 and 2, when the sun's pretty much right ahead. You can see my solar panel on the ground. It's quite lit up. And my other array on top is obviously getting quite good sun. And I don't know if you heard the AC running, keeping it cool inside. Before we go inside and see what's going on, I do want to point out the AC300 and the B300 are not meant for outside use. I have to protect them from the sun from getting beat down and overheating, but also from the weather. I'm just borrowing this tiny home cabin office, so I can't drill any holes to run cabling through it. All right, we'll go inside here. I did grab a thermometer so we can read a little bit better. It says we're 64 degrees inside right at this point right here. The AC, I think only the fan's running. We come over to, yeah, we're only using 151 watts. So really just the fan on that and keeping the refrigerator going. Of course, the refrigerator is still nice and cold. Look at that. Can't even read it. Very cold. Now the panels themselves are putting out 1.3 kilowatts, so we're still not even peak sunlight. We have 2 more hours before we get peak, and we're only using 150 watts. So we are charging the batteries. So that battery is being charged, and that one is also currently at 69% and 73%. So I'm going to continue to let that run with the AC going and let the solar panels charge them up. Let's go inside my RV and we'll discuss what we've learned. Okay, this is what I got put together. I put some notes together. So first off, I want to thank my good friends All-Star Storage here in Apache Junction, Arizona, for letting me borrow their tiny container home office setup. They didn't have to do that. They just let me borrow it in order for me to run these tests. So thank you very much. It's great to have good friends. If you're looking for a container home or office, maybe reach out to them. So what did we learn with all these tests? The first thing we learned is that, yes, the AC300 from Bluetti will run a standard RV roof AC unit. No soft start needed, just plug it in, run it just fine. But I think it's probably only rated around 25 amps. So our normal roof AC in the heat of the day in Arizona heat is going to pull about 18 amps. So that would only leave 7 amps of power to use for everything else. The second thing we learned, which was the most important thing we learned, and why we even did this test, because in previous tests I've done, people say, yeah, the systems work in full sun. Yeah, run roof AC for a few hours and the battery's dead. And then you're stuck with no power at night when the sun goes down, and it gets hot at night too. So what we learned is that with this system, the AC300 with 2 B300 lithium iron phosphate battery modules, we didn't have that problem. I initially set it for 85 degrees. We ran that for 2 days like that. My buddy said, because I was out of town, didn't have any problems. Batteries never went dead. We had power all through the night. It kept it about 85 degrees. I came in very early this morning, before the sun came up. I put the power down to, or the AC down to 60 degrees, depleted to about 65%. But as soon as the sun started charging again, they never went dead. So even going way too cold, running the AC more than you're supposed to, the batteries didn't die. So it looks like it's a very viable solution to run an AC, refrigerator, and 110 outlets in an off-grid setting. Now keep in mind, I did have 2 solar arrays. One I'm calling a 900 watt solar array. The other one I'm calling a 700 watt solar array. About 1600 watts, but of course it's rated to handle up to 2400 watts. So we didn't even utilize all the solar capabilities on the AC300. However, it's definitely not portable. Each one of those battery modules weighs about 80 pounds, and then the AC300 is 45 pounds by itself. There's no wheels on this thing, so you're gonna have to be lugging it around quite a bit if you want it to be portable. 2, the side cables that connect the batteries to the AC300, very bulky, take up a lot of space with that. My big irritation is that in order to access all the features through the phone app or the Bluetooth connectivity app, you do have to connect the AC300 to a Wi-Fi signal with internet, and I guess merge the two together. I'm off grid. I don't have Wi-Fi internet here. It's kind of irritating that it couldn't just all be done through the Bluetooth connectivity. To answer some of the most important questions you're going to have is, how much does it cost? The AC300 by itself, looks like Bluetti has it listed for $1,400. Each battery module, the B300, I saw them priced around $1,900 a piece, which sounds pretty excessive, I will grant you, but I consider Battle-Born batteries to probably be the gold standard as far as lithium batteries. So a standard 12-volt Battle-Born battery, we're going to call it about 100 amp hours. At 12 volt, that's 1200 watt hours. The B300 has 3072 watt hours. So you would need a little less than 3 Battle-Born batteries to be one B300. Each one of those Battle-Born batteries is priced out about $925. So you get 3 of them, because you can't get half of one. That's about $2,700, $2,800. And then of course you still have to wire it up. So the B300, still, even though it sounds expensive, it's actually a pretty good deal, and you don't have to wire it up. More importantly, if you did get a previous Bluetti product like an AC200 Max, like I already did the review on, the B300 is apparently compatible with the AC200 Max. So they have a bundle package, so you get the AC300 and then 2 B300 modules, so all 3 of them together. It's about $5,200. Again, yeah, that seems pretty expensive. I agree with you. But when you start to break it down, like an Onan generator, if you want to get a gas generator, you're looking at about $4,000. So I tried to do the math. Check my math. Please do check my math. $5,200 divided by 6 is about 867 gallons of fuel. All right, that sounds like a lot of fuel too, but if we're using 5 gallons a day, after 173 days, the Bluetti AC300 bundled with 2 of these batteries has paid for itself. After that, it's free power, no more fuel, no more noises, no more maintenance. So if you are going to be using a generator quite a bit, fuel prices, when they get up to $6, it's kind of a no-brainer. Yeah, if fuel was $2 a gallon, I would still be on your side of saying I'd still go with generator, but not having to listen to generator noise or do the maintenance on it, or for emergency uses, you don't use your generator all the time, so in the off chance you finally do need to use your generator, but it's been 2 years since you've used it and it doesn't start, why did you even have a generator? With the Bluetti power UPS, it's just there. It's going to work. It's no moving parts. Lastly, after writing all my notes, cleaning up the test facility, we've had the system charging up and the AC is still going. Let's go see how it's doing. All right, so it's still nice and cold in here. I didn't move the thermometer, but it is still 60 degrees. AC's running there. So we've been charging for about an hour while I did everything. We're up to 84%. We're putting out 1.5 kilowatts. The AC, like I said, is running, and we are charging the battery. So we were about 70%. So within an hour, we already brought it up 14%. 86 there and 82 there, which makes sense because we have the two different arrays that charge at a little bit slower rate for the other one. I really hope you guys appreciate this video. I did my best to do some what I think are real world applications on it, but it is a pretty good system. Besides having to create your own solar array and wiring setup, it's all pretty much self-contained in there. You didn't have to worry about battery wirings, overcurrent protection, disconnects, MPP charge controllers, do all the math on everything. It has a pretty robust warranty on it. I'm tired. I have to get across the other side of the country again and catch a plane. Thanks a lot for watching, guys. Oh wait, there's one thing I did forget. I should really learn how to read my own notes. Bluetti did give me a link to a discount code to their website. I will put that information in the description. Please don't buy anything just to support me or the channel. I'm just happy to do these tests for you guys. I was given a very rare opportunity to test this system out to try to answer questions for you guys. And then I'll also do that, that link right about there. So you can go to Bluetti's website too. It's a beautiful, but it is a sunny, but it is a very sunny, but it is a perfect sunny day here at the shop, and so we can at least see if it runs the roof AC on an RV without. So we can see if it runs a roof AC on an RV without. But just like the Bluetti 200 Max, but just like the Bluetti AC, the Bluetti 3000, the AC300, and while you could utilize the Bluetti 300, and while you could use, because naturally the generator died. To provide me a off-grid office, and I think this is more useful information anyways. If you noticed, these panels are not pristine. They have some deficiencies and some defects in them too, which is why I got them so cheap. They're only $50, and that's only 10 gallons of fuel. So each one of these, after 10 hours, they've paid for themselves. Well, I don't have a Bluetti AC300 on my motorhome, so I have to listen to the generator drone on because it's pretty stuffy and hot in the RV, but I'm gonna get some sleep. All right, now I just have to put all my test equipment back away in my house. I guess it wasn't entirely high-tech. And then I'll put a link, I don't know,